And so question 10 is an extension one. So just a reminder that we're not going to teach you on any of the, I'm not going to test or quiz you on any of these things, although they are pretty helpful to know. So there's a couple of ways that you can do these questions. I'm going to do it one way. You might have done it another way, and hopefully you got the same answer. I'm going to do A, then D, and then B and C will just fall out of being able to do choice thing. So suppose I have some initial margin of error 1. So I'm going to call it M1 is my initial margin of error. So then suppose I have some second margin of error, which is going to be, say, the new margin of error. So the goal of the question is to reduce the margin of error by a factor of 2, right? So this means that I want my second margin of error to equal 1/2 of my first margin of error. So put another way, if we want to think about it in terms of ratios, this is saying that M2 over M1 would equal 1/2. Right, so I want to cut my margin of error by a factor of 2. Right, so let's think what we know. Right, so my first margin of error is going to be 1 over the square root of some sample size. I'm just going to call it N1. My second margin of error is just going to be 1 over the square root of N2. So let me plug these things in. So I'm going to get 1 over the square root of N2 over 1 over the square root of N1 equals 1/2. So there's a lot of different things we could do at this point. You might want to cross multiply. You might want to square both sides. I'm just going to cross multiply just because I feel like that's easier algebraically for students. Although, I don't know, do a lot of fancy stuff. So when I cross multiply, I'm going to get 2 over the square root of N2 equals 1 times the square root, 1 times 1 over the square root of N1. All right, so then we can square both of these, right? So if I square both sides to get rid of the square roots, I'm going to get 4 over N2 equals 1 over N1. Right, so then if I cross multiplied one more time, I'm going to get 4N1 equals N2. Basically saying here that my new sample size, aka N2, is 4 times the initial sample size. That would be N1. Right, so to reduce the margin of error by a factor of 2, we have to quadruple the sample size. All right, so if I looked at D, we're going to get very, very similar argument. In fact, I could take everything that I've done here. I'm going to actually just take this for a moment. I'm going to duplicate that because it's the same idea. And instead of having M2 over M1 equal 1 over 2, now M2 over M1 is going to be 1 over some value K. We would get a pretty analogous argument. In fact, everything that we would do at this point is just going to be replaced by a K. So I could do that whole cross multiplying thing. We're going to get K over the root of N2 equals 1 over N1. Right, so I get 1 over the root of N2, 1 over the root of N1 is 1 over K. We'd cross multiply. We would get K over the root of N2, 1 over the root of N1. We would square both sides again. So K squared over N2 equals 1 over N1. And again, we do a little bit of cross multiplying to get N2 equals K squared times N1. So what this means is that our new sample size is K squared times the old sample size. So that's pretty big, right? So if we looked at, say, question C, right, our K value is 10. I want to reduce my margin of error by a factor of 10. So K squared equals 10 squared, aka 100. I need a sample size that's 100 times what my initial one was. So if I had 40 people, now I need 4,000 people to achieve that margin of error. In question C, my K is 4. So k squared equals 16. So if I had, say, 80 people in my initial sample size and I want to reduce the margin of error by a factor of 4, 80 times 16 is, oh, why did I do that? Would be 1,280. You need 1,280 people now in your sample, right? So notice kind of like this trade-off, right? We want less error, but it's not like we can just increase our sample size nicely and linearly. We actually have to square it, right? So there's this point of like diminishing return where you're like, it's just too prohibitive cost wise, time wise, money wise, time wise rather, in, for me to try to get my error down past a certain point.